Good morning, everyone. I'm from Farm. Welcome to the course Food Waste Management. This is the practical activity that belongs to the first module of the study unit Food Waste Prevention, Reduction, Identification, Quantification, and Measurement. This practical module introduces you to systematic measurement of food loss and food waste across different stages of food supply chain. Through real-world case studies, you will analyze operational scenarios, identify potential sources of food loss and waste, and select the most appropriate quantification method. By actively applying this method, you will develop the ability to justify methodological choice based on data availability, accuracy, and practical constraints. This activity can help you strengthen analytical skills, promote system thinking, and prepare you to generate reliable data that underpin effective food waste prevention and reduction strategy. By the end of this activity, you will be able to select and apply suitable methods to measure food waste level in different contexts. Let's start with a very simple matching exercise. In this activity, you have to match the measurement activity in the first set to the right quantification category on the second set. In the first set, which is measurement activity, we have asking household to record discarded food in a weekly food waste diary. Then weighing food left over from household meal using a kitchen scale. Using supermarket inventory and sale data to estimate expired food product. Estimating national food waste using statistical data and consumption model. Counting unsold bread loaf at the end of the day in the bakery. And finally, we have calculating food waste in a processing plant using input and output mass balance. In the second set, we have four category quantification method, which are direct measurement, record-based, self-reporting, and modeling and estimation. We will analyze this scenario one by one together. In the first scenario, we have asking household to record discarded food in a weekly food waste diary. So in this case, the reason you obtain is what the participant give you. It doesn't come from any physical measurement or recorded data, so this is a self-reporting method. The activity of the results rely heavily on the memory, the honesty, and commitment of the participants. Weighing food left over from household using a kitchen scale. In this case, the quantity of waste can be obtained from a physical measurement with a kitchen scale. So this is a direct measurement method which provides accurate and objective quantitative data. In the third scenario, we have using supermarket inventory and sale data to estimate expired product. In this case, the quantity of expired product is calculated from the information about purchase, sold, and remaining product in stock. So it comes from the recorded information, not some physical measurement. And the reason you obtain is the secondary data. This can be classified as record-based methods. Estimating national food waste using statistical data and consumption model. At national level, direct measurement record-based method, and even self-reporting are not feasible. So you have to use the statistical data set to estimate the quantity of food waste. For this reason, this is the modeling and estimation method. Counting unsold bread loaf at the end of the day in a bakery. So the rule counting in the statement has already given away the answer. This is the counting method in the category direct measurement. Since the bread loaf are sold in single unit, you can easily count it and write down the total number of bread loaf at the end of the day. Calculating food waste in a processing plant using input and output mass balance. Since the input and output data are included in the production record, um, this can be classified as record-based method. So there is a summary of the answers for this exercise, where each scenario is matched to the right quantification method category. We have the second exercise, which is about food waste quantification in a university canteen. In this scenario, a university canteen serves breakfast and lunch to students, academic staff, and administrative personnel. The canteen prepares meal on site using fresh and semi-processed ingredients. All ingredients are screened and selected before acceptance. So, this implies that all the materials that come to the canteen has good quality. Service includes a self-service zone for side dishes and portion main course which are prepared in advance. Meals are served 5 days per week, around 500 to 700 meals per day. At the end of the day, all remaining food is disposed according to internal hygiene and safety policy. For this scenario, we have two starters. The first task is identify and list all potential food loss and food waste sources. The second one is determine the most suitable quantification methods for each waste and explain the reason for the choice. In order to resolve this exercise, I would like to suggest to you a procedure. Since the university canteen is a relatively complex process, it starts from the reception of raw material to the consumption of the food at the canteen. For the first step, we should break down the entire process into smaller operations. In this way, we do not miss any waste source. The second step is for each stage, you must identify and list all potential food loss and waste streams. The third and the most important step is the analysis of the characteristic of each waste stream, including amount of waste. We consider the scale and location of occurrence. Physical and characteristic. You must determine whether the waste is solid or liquid. Is it mixed or unmixed? And finally, the visibility of the waste. Is the waste visible or hidden? Can you measure it or you can only calculate it from some other information? The last step is the selection of the most appropriate quantification method. based on the analysis that you have performed in the third step. Let's solve this exercise together. We start with the first task, which is the identification of loss and waste. The process in the university canteen is broken down into smaller operations. Here we have storage and preparation, cooking and production, service stage, and consumption. In the first stage, since we assume that all the quality control has been already done before the material go to the canteen. So it means there will be no further quality control at the reception. The waste in this stage could be spoiled raw ingredients due to improper storage. Ingredients expire before use. The trimming loss, in particular, the excessive trimming loss, like vegetable peel, excess fat. Ingredients are prepared but not used. In the cooking and production stage, the waste could be overcooked or incorrectly prepared meal. It could be some food that is too burnt or overcooked. Batch rejected due to quality or safety issue. Excess food prepared due to incorrect demand forecast. Actually, this last waste can be measured into the service stage because the excess food prepared then will become the unserved food. At service stage, we have the unserved portion dish. Unserved self-service food discarded at the end of the day and contaminated food during the service. They could be fallen or touched accidentally by customer. At consumption stage, we have plate leftover, whether they are untouched or partly consumed. Now we pass to the second stage, which is the selection of quantification method and explanation, which corresponded to the third and the fourth step. In the first stage, for the spoiled raw ingredients due to improper storage, the spoiled raw ingredients are physically separated from the usable material and they will be discarded before cooking. So the waste is visible, localized, and generated at identifiable moments. For this waste, we can use direct measurement, in particular direct weighing, because considering the size of the canteen, this quantity could be weighed by an industrial scale. The ingredient expired before use can be measured by record-based method or direct weighing as a complementary method because the expiration is usually recorded in inventory or stock data. The trimming loss can be weighed directly because the trimming loss occur at defined preparation step and also it can be collected in dedicated container. Direct weighing for this reason allows the quantification of this kind of loss. Ingredients prepared but not used. So this kind of waste are usually discarded in bulk and it can be weighed before disposal. For this reason, we can use the method direct weighing. The production and preparation record can also support the analysis. by linking the waste to planning errors or over preparation. As the next stage, cooking and production. Overcook or incorrect prepared meal are rejected from the service and discarded. So we can use a method direct weighting that captures this loss accurately, and also it allows identification of waste caused by human errors or some error of the system of the equipment. Batch rejected due to quality or safety issue. The rejected batches are identified and separated at the moment. So the weighting can provide precise quantitative data, while quality and safety record can help link the waste generation to specific non-compliance event. The over preparation, so the overproduction is translated into unserved food. In the service stage, the unserved portion dish can be quantified by using the counting method because the dish are uniform and can be easily counted. Direct weighing can be an additional method because it provides additional precision when portion size varies just slightly. Unserved self-service food discarded at the end of the day. So this kind of food, still they are unserved, they still remain in the serving trays at the end of the service. We can use direct weighting to quantify this kind of waste. Food contaminated during service can be quantified by using the direct weighting method because this kind of waste will be discarded immediately for safety reasons. So they are separated at the point of generation. A consumption stage, assuming there's no other source of waste, we have bread left over, whether untouched, so intact, or partly consumed. This waste can be measured and analyzed using the waste composition analysis that allows the sorting and weighting by food category. It can provide insight into which food are most frequently wasted so the canteen can adjust the preparation. Also, the direct weighing alone would not provide this level of detail because it can measure only the total quantity of waste, not the detailed information about the category of waste. The overall waste of the canteen can be estimated using the record-based method and mass balance. This approach can capture both visible waste and hidden loss and allow the continuous monitoring over time with minimal additional workload. But it can only estimate the total quantity, not the detailed information. So there are some key takeaway from this exercise. Given the canteen capacity, we can serve about 500 to 700 meals per day. It can be classified as small to medium-sized facility. So the direct weighing in this case is feasible because they can use an industrial scale to measure the waste. The university canteen generates food loss and waste at multiple operational stages. Because waste streams are different in visibility, composition, and scale. There's no single quantification method is sufficient. For this reason, we have to combine several methods to ensure the accurate and actionable data for waste production planning. The next exercise is about the food waste quantification in a ready-to-eat food processing plant. So we will consider a scenario in the food production stage. A small-scale ready-to-eat fruit processing plant produces fresh cut fruit products like, for example, sliced apple, pear cup, and mixed fruit salads, packed in plastic container under refrigerated conditions. The processing capacity of the plant is range from 1 to 3 tons of fruit per day. The plant operates 5 days per week and includes the following main operations. The first step is receiving and cold storage of raw fruit. Then we have another preliminary operation, which is washing, peeling, and trimming. The next step is cutting, and then we have packaging and labeling. And finally, cold storage of finished product before distribution. The products are distributed daily to supermarket. All discarded material are handled according to internal quality and food safety procedures. For this scenario, we also have two stages that are similar to the previous exercise. The first one is identify and list all potential food loss and food waste sources. The second task is determine the most suitable quantification methods. It could be one or more methods for each waste and explain the reason for the choice. So in this exercise, I have already gave you the detailed operation of the work process. The first operation is raw material reception and storage. The waste and loss could be fruit rejected due to visual defect or unfit size. Since the processing plant process the food with an automated machine, the fruit must have a certain standard. So unfit size could also be a cause of waste. Spoiled fruit due to inappropriate temperature or prolonged storage, and fruit damage during handling. This is a kind of physical damage. During washing, peeling, and trimming operation, the excessive edible flesh removed together with peel due to inefficient cutting, whether manual or mechanical, so automated cutting. Fruit damage during washing. This is also a physical damage and excessive trimming loss. In the cutting operation, we have product loss due to cutting errors, product drop during transfer between equipment, and in packaging and labeling stage, we can have the waste like product loss during filling operation. It could be spill out of the packaging. Package rejected due to sealing or labeling errors. In the final step, post-production, which is storage, we can have the expired finished products. Products are discarded due to temperature fluctuation and return product from retailer. It could be from many reasons. In the first stage, the fruit rejected due to visual defect or unfit sight are physically separated during the reception and quality control. They are discarded before processing. Since the waste is clearly identifiable and localized as a reception, we can use direct weighting that provide accurate and objective quantification data. Spoiled fruit due to inappropriate temperature or prolonged storage. This kind of waste are removed from storage immediately and can be directly weighed using the direct measurement method. The storage record like temperature logs or storage duration data can support the interpretation of the result by linking the waste quantity to the storage condition. Fruit damage during handling can be quantified by using the direct weighting because this kind of waste are discarded shortly after the damage occurs. Since the waste are visible and are physically separated, we can use a direct measurement method. During washing, peeling, and trimming operation, excessive edible flesh removed together with peel due to inefficient cutting can be estimated or calculated from mass balance. A portion of edible flesh may be lost together with the peel and is not always fully collected as solid waste. So the mass balance can capture this hidden loss by comparing raw material input with output and byproducts. Direct weighing can be a complement method. Fruit damage during washing can be quantified with the direct weighing method because they are removed from the process and discarded. So this waste is tangible, visible, and generated at a defined processing step. Excessive uh, trimming loss are produced continuously at preparation station and can be collected and in dedicated container. The direct weighing can be applied during cutting operation. The product lost due to cutting errors. They can also be called as the off-spec product. They are generated by cutting errors that are typically removed and discarded. We can apply the direct weighting method to quantify this kind of waste. And besides, also mass balance can be used to capture the small fragment of juice loss that are not easily to be measured by direct weighing. Product drop during transfer between equipment. This kind of loss can be scattered everywhere. We should use a mass balance method to capture this kind of loss. During packaging and labeling, product loss during filling operation. The loss during this operation often occur as a small spill or residue that are not collected as a solid waste stream. So we must use mass balance to capture this kind of hidden loss by comparing the product input and package output. Package rejected due to sealing or labeling error. They are finished product and they are also standardized unit. The counting method could be applied because All the units should be similar to each other. The rejection reason are also be recorded. So also the record can support the analysis and trend monitoring. During the post-production phase, expire the finished product can be quantified using record-based method because the inventory system typically record the production date, shelf life, and expiry. Also, the counting could be used as an additional method to cross-check product discarded due to temperature fluctuation. The product discarded due to cold chain failure are physically removed and can be counted awake. The temperature monitoring record can also help identify the root cause and timing of the loss, so we can also monitor the trends. Return product for retailer. This kind of waste are documented through return note and invoice. So counting and weighing can be applied to verify the quantity and assess the economic and environmental impact of the return. For the overall waste of the production plant, we can apply mass balance and record-based method. A mass balance approach is the most suitable to quantify the overall waste because it integrates the full system and comparing own input and own outputs. Record-based data like production logs, inventory, rejected pack, and returns provide the necessary input values and help monitor trends over time. So the summary of this exercise is the ready-to-eat fruit processing plant generate both visible and hidden food loss throughout the production chain. Direct measurement, record-based method, and mass balance must be combined to obtain accurate and comprehensive quantification data. This integrated approach supports effective identification of waste hotspots and the development of targeted prevention strategy. Thank you for your participation in this practical activity. I hope the scenario we have analyzed today give you good example about how to apply the quantification method correctly. Goodbye and have a nice day.